Hi, my name is Thomas Kim. In this session of video, we will learn how to implement, how to make Tower of Hanoi algorithm. Say initially we are going to move disks from tower A. This is tower A, disk in tower A to tower C like this. If we have just one disk, we can move from here to here like this. If we have two disks, we first move to in the middle center to center tower, then move another bigger disk to the target, then we move this disk to here. Then this is two disk algorithm. Okay. Now we try with the 3 disk algorithm like this. 3 disk. We move 2 disks to the center, then here, then here. This is 3 disk algorithm. Let's try once again 3 disk algorithm. We move 2 disks from A to B, then the biggest disk to C, then we move 2 disks to C tower. Now we try with 4 disks. We have 4 disks like this. When we are now moving 4 disks, then we first move 3 disks like this. Then 1 disk. Then these 3 disks like this. This is actually the algorithm. Now let's try with 5 disks. Now we have 1, 2, 3, 4, 5 disks. Then we first move 4 disks here like this. Then 1 disk. Then 4 disks to tower C. Please remember, we need 3 steps. I will try from 1 disk once again. When we implement 1 disk, we can directly move like this. This is 1 disk algorithm. Now we make 2 disk algorithm. To make 2 disk algorithm, this is step 1, step 2, step 3. For the 2 disk algorithm, now we are moving 3 disks. This is step 1, step 2, step 3. Okay, now we are doing 4 disk algorithm. This is step 1, step 2, step 3. So we are using always we use 3 steps. 1, 2, 3, 4, 5 disks. Step 1, step 2, step 3. You may argue like this. Hey, come on. We are not going to move like this. We cannot move like this. Well, try to think like this. Okay. Say, when we move 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 disks from tower A to tower C. When we move 5 disks from tower A to tower C, we use 4 disk algorithm. 1, 2, 3, 4. We use 4 disk algorithm to move it here. Okay. Then we move it here. Then we use 1, 2, 3, 4, 4 disk algorithm again. We use 4 disk algorithm to move it here. Okay. You may say, oh, come on, what is 4 disk algorithm? Okay, I will tell you what is 4 disk algorithm. This is 1, 2, 3, 4 disk. Then we use 3 disk algorithm. 3 disk algorithm to move from here to here. Okay, then here. Then we use 3 disk algorithm again. 3 disk algorithm to move here. Hey, what is 3 disk algorithm? Okay, 3 disk algorithm is this. This is 3 disks. We move 2 disks here, then 1 disk here, then we use 2 disk algorithm to here. This is 3 disk algorithm. Then you say, what is 2 disk algorithm? This is 2 disk algorithm, 1 disk here, 2 disk move here, then move last here. This is 2 disk algorithm. So to move 3 disks To move 3 disks, we use 2 disk algorithm. To move 3 disks from A to C, we use 2 disk algorithm like the once, step 1, step 2, step 3. So we use 2 disk algorithm twice. Once like this, second, okay, we just concentrate this 2 disk algorithm. We use 2 disk algorithm once, then we move 1 disk, then we use 2 disk algorithm again here, like this. Then you may ask me, what is 2 disk algorithm? This is moving 2 disk is 2 disk algorithm. We use 1 disk algorithm, then we move disk, then we use 1 disk algorithm, like this. So move 5 disk to move 5 disk from tower A to tower C, we use 4 disk algorithm to move 4 disk from tower A to tower B. Then we move a disk, 1 disk here. Then we use a 4 disk algorithm again to move 4 disks from tower B to tower C. This is recursive. This is called a recursive method. Okay. I will explain once again, just one last time. Then we will implement this into C++ code. One, two, three, four, five, six, seven, eight, nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 disks. We are going to move it here. Then we use 8 disk algorithm. We use 8 disk algorithm to move 8 disks to tower B, like this. Then we move 1 disk. Then we use 8 disk algorithm to move it all disks here, like this way. What is 8 disk algorithm? Okay, 8 disk algorithm is this. We now have 8 disk algorithm. To implement this is 8 disk. To implement 8 disk algorithm, we use 7 disk algorithm. So 7 disk, we move 7 disk algorithm like this. Then here, then we use 7 disk algorithm again, like this. Okay, then what is the 7 disk algorithm? 7 disk algorithm is something like this. We have 7 disk. We use 6 disk algorithm like this. Then we move lastly. Then we use 6 disk algorithm like this. Then you may ask, what is the 6 disk algorithm? 6 disk algorithm is something this. So we have 6 disk. We use 5 disk algorithm. Then move here. We use 5 disk algorithm like this. So this way we can move any number of disks from tower A to tower C. Okay. So if we are going to move from tower C to tower B, for example, from tower C to tower B, for example, 1, 2, 3, 4, 5, 6 disks, then we use 5 disk algorithm to move it here, then move it here. We use 5 disk algorithm, move it here, like this. Then we move all towers from C to B. If we are going to use 1, 2, 3, 4, 5, 6 towers, going to move 6 towers to tower A, from tower B to tower A, then we use 5 disk algorithm to move 5 disks to here. Then we move it here. Then we use 5 disk algorithm again to move it here. This is the basic principle of Tower of Hanoi algorithm. I will move to my computer, then I will implement it in C++ code. I made an empty file in advance. This has no C++ code yet, and I made some drawings like this for configuration for easy understanding. I will initially include some header files, ostream, and include string, then include deque, like this. Okay, then we will make a function int main,
Then we test it first. We will first compile. Save it. We see Hanoi CPP. I used GNU compiler. Okay, it compiled and worked. Now we will try with Microsoft compiler. Both works. Now, before explain, I will introduce how to use deque. We will use deque as our stack. std, deque, and int d. We can initialize 1, 2, 3 disks like this. You have to understand how to use deque data structure first. Then we will print out the elements like this. Auto, for example. I will say auto idx index disks begin, disks end, plus idx. We can now print out So I am trying to explain how to use the deque class first. I saved it and I compile, build, and run. So 1, 2, 3 is executed, displayed like this, deque. Now we will make it into a function. Now we copy this. Like this. We have to return. We have to change it to OS. OS is argument, stream argument, like this. Then we try. Like this. Now try run them. Okay, it still works. Now we will make it more error free. We enclose this part. And we want to print out curly brace, and here we want to close with curly brace like this, then saved. Now we try it once again. Sorry. Okay, it works like this. I don't like this trailing comma. I want to remove that. How to do that? We can fix like this. Instead of this, I want to change it like this. I changed it, and here okay, I fixed like this. Now let's try it. Okay, it cleanly displays. Now if we want to string disk, then you can say red, green, blue. Save them. Now works. So I explained our IO stream. Since we understand how to use this, before I close, I will try one thing more. Here I will define std string. I will define an alias like this, disk type. I changed it. I added alias like this. I change it like this, and we haven't changed it anything. Now we can say disk type disk. We get the last element of disk. This disk has disks. Then we say disk front. Then we front of disks. So I want to let you know what this command means. Okay, so let's see. I made a mistake here. Okay, so front gives the first element of this string. Red is the first element, and we will try once more. Disk type, I would say front disk, back disk. Save it. So front disk is red, back disk is blue. Please remember this configuration. And lastly, we say remove front. Remove here. We do one more operation. Disks pop. Sorry. Pop back. This is back disk. After popping, let's see what happens. Back disk. Back disk. Now let's see. Okay, RGB, front disk red, back disk blue. Now we remove here. We remove pop back. Pop back means we remove last disk. Then disk after back removed. Left is red, green. So front disk of this front is still remain the same. Okay, so I hope you understand what pop back means, and we can also remove a front element like pop front like this. Now we understand how to use the deque data class data type in Visual C++ standard library. Now we are moving back to Tower of Hanoi now. Since this is our initial condition, initial stage, we will make this into algorithm. Here, we will name tower like this: enum tower, tower A, tower B, tower C. Like this. Then we will make another operation, another friend function, ostream operator, std ostream. You can just say tower like this. Switch tower. We will say case tower A OS A. Return OS. Case Tower B. OS B. Return OS. Case Tower C. OS C. Return OS. Default return OS. Now let's see how we use this enumeration. Tower from tower A std cout the name of from tower from and there. So we can use this enumeration as name of tower. We can add more, from to use. To will be C tower. We'll use B as tower. Name of from tower, to tower, use tower, like to use. See? ACB. So you understand how to use enumeration. Now we are going back here. Initially, say we need disks like this, 1, 2, 3 disks. So we make Tower of Hanoi. Like this. We defined here std deque disk type like this. We will name it stack. Okay, stack has like this configuration. Then we can name it stack. We can change element of stack. We say disks. Then tower, we will name it from tower. We will get disks like this, 1, 2, 3 disk stack. Then we move from tower to tower. We will use this tower. We will move disks from tower to tower using use B tower as intermediate. Okay. So we need, I will split it to view the configuration simultaneously like this. We need from tower, use tower 2. This is our function. Here, see, if So we are initially, this is initial configuration. That now step 1, if we move n minus 1 disk from v minus n minus 1 disk, the size of disk is disk size gives the number of disk. Okay, so we have to move we first test if disk the count of disk. Okay, so if disk size is 1, it means we have one disk. So in case we have one disk, for example, we can move one disk from here to here. So if we have one disk, you say, I will make another function here. I will label it disk name. This is disk tower from tower 2. We will print out move disk from 2 2. So we move disk from tower to tower like this. So we made a move disk. We are moving here when disk is 1, only one disk. Move disk since we have just one disk, this is just one disk, one element, the first element. Then from tower to tower, we are moving from tower to tower just one disk, in case of just one disk. Else if greater than 1 means 2 or more, then we are going step 1. This is step 1. We are moving this n-1 disk from use to we move n-1 disk. In case in this configuration 3 disk, so we move 2 disk. Before we move 2 disk, we copy 2 disk to a place. So disk stack. No, we will save the last disk first. Disks back. We save the last disk. I say bottom disk. Then we remove bottom disk. This is not actually step. Save bottom disk to bottom disk. Remove bottom disk from disks. Okay, then we save this configuration, two disks, stack, save, disks. We save the disks. Then we move Hanoi, we move this disk, save the disk. Why we can use this disk too? They are because the same. I will move it. Please note that we are implementing step 1. This is step 1. Step 1, move n-1 disk. It has n-1 disk because we removed one, the last one, bottom one. From we are moving to use, to target will be use. We move 2 disks from tower A to tower B. So tower B is use. And we use intermediate 2 to use. We are moving the 2 disks from tower A to tower B. Okay, tower B. Tower B is use. This is target. This is from target. This is intermediate. So this is the configuration. Intermediate. 2 as intermediate. This is step 1. Now step 2. This is step 2. We move this disk to here. We saved this disk. We move disk. This is the disk, the bottom disk. We move bottom disk. From 2. We move bottom disk from bottom disk. This is n's bottom disk. We move bottom disk from A to C. From 2. Like this. The last step, this is third step, from use, we saved this disk, from use to, we use from as intermediate, like this. This is the third step. We are implementing the third step. Then everything is done. The algorithm is completed. Now save them. Saved it. Now try it. We first make stack disks. We made a string as string. So I say disk, disk, disk 1, disk 2, disk 3. We made 3 disks. Now we move those disks Hanoi, disks, tower, from A, tower, use B as intermediate, tower, C. Okay, Control S, saved, and we compile. Wow, it worked without bug. See, this is the algorithm. Move disk 1 from tower A to tower C. Disk A from tower B to tower C. So we will count, and this is actually the algorithm. 1, 2, 3, 4, 5, 6, 7. 7 steps required. So we cannot, in this case, if we cannot understand, I hope you understand. So this is the basic algorithm of Tower of Hanoi, and I will extend this algorithm to, in my next video, I will extend this algorithm to see all tower configurations. or how disks are moved, how this gives how we have to move disks from tower A to tower B to tower C. In my next video, I will show how we move all the configurations, each step. This shows the steps, but I want to demonstrate how to display all tower configurations at each move of disks in my next video. Thank you for watching.